Water is life. We all know this. We need it to drink, to cook, and to grow our food. But clean water is more than just a necessity. It's a fundamental human right. Without clean water, our health is at risk. Dirty water can carry harmful bacteria, viruses, and parasites. These can cause diseases like cholera, typhoid fever, and diarrhea. Every year, millions of people, especially children, get sick from drinking unsafe water. Access to clean water is also crucial for education and economic development. When children are sick with waterborne illnesses, they miss school. When communities lack safe water sources, they spend precious time and resources collecting it from faraway places. Clean water is the foundation of a healthy and prosperous society. It's essential for our well-being and for a sustainable future. We can't always see what's lurking in our water. Microscopic contaminants can turn a clear, refreshing glass of water into a serious health hazard. Biological contaminants, including bacteria, viruses, and parasites, pose a significant threat. These tiny organisms can multiply rapidly in water, causing widespread illness. Chemical contaminants, such as pesticides, heavy metals, and industrial waste, are another concern. They can seep into our water sources from agricultural runoff, industrial discharge, and even household plumbing. Physical contaminants like dirt, sand, and debris can also affect water quality. While they might not always pose a direct health risk, they can make water unappealing to drink and can clog water treatment systems. Protecting our water sources from contamination is crucial. This involves responsible waste management, sustainable agricultural practices, and strict regulations on industrial discharge. Water's journey from its source to our taps is a fascinating and intricate process that often goes unnoticed in our daily lives. It all begins with natural sources such as rivers, lakes, and groundwater aquifers, which are the primary reservoirs of fresh water on our planet. These sources are continuously replenished by rainfall. Rainwater collects in watersheds, which are areas of land where all the water under it or draining off of it goes into the same place. This water then slowly percolates into the ground, recharging aquifers and maintaining the flow of rivers and lakes. However, the quality of these natural water sources is not always pristine. They can be affected by various forms of pollution. Pollution from human activities such as agricultural runoff, industrial waste, and urban development can introduce harmful contaminants into these water sources. Pesticides, heavy metals, and other pollutants can degrade water quality, making it unsafe for consumption without proper treatment. Climate change is also adding to the challenge, causing more frequent and severe droughts and floods. These extreme weather events can disrupt water availability and quality, making it even more difficult to manage and protect our water resources. Once water is collected from its source, it embarks on a journey of purification. This crucial step ensures that the water is safe for human consumption. The purification process involves several stages, including filtration, sedimentation, and disinfection. These processes work together to remove contaminants, pathogens, and impurities, ensuring that the water meets safety standards. Water treatment plants play a vital role in this journey. They use a combination of physical, chemical, and biological processes to purify our water. Skilled workers and advanced technology ensure that the water reaching our taps is clean and safe, ready for us to use in our daily lives. For centuries, people have relied on simple yet effective methods to purify their water. These methods have been passed down through generations, ensuring that communities have access to clean water even in the absence of modern technology. Boiling is one such method, used to kill harmful bacteria and viruses by heating water to a rolling boil for a sustained period. This method is particularly effective in eliminating pathogens that can cause diseases, making it a reliable choice for many. While effective, boiling does not remove chemical contaminants and can be energy intensive. It requires a significant amount of fuel, which can be a limiting factor in resource-scarce environments. Additionally, the taste of boiled water may not be appealing to everyone. Filtration is another traditional method, using materials like sand, charcoal, or cloth to remove larger particles and some impurities. This method can be easily set up with locally available materials, making it accessible to many communities. Sand filters, for example, can effectively remove sediment, turbidity, and some bacteria. The layers of sand trap particles as water passes through, resulting in clearer water. However, regular maintenance is required to ensure the filter remains effective. Charcoal filters are known for their ability to absorb certain chemicals and improve taste and odor. Activated charcoal has a large surface area that can trap contaminants, making it a popular choice for improving water quality. Settling is a simple yet effective method for removing larger particles from water. This method relies on gravity to separate heavier particles from the water, allowing them to settle at the bottom of a container. By letting water stand undisturbed in a container for a period of time, heavier particles settle to the bottom, allowing clearer water to be collected from the top. This method is often used as a preliminary step before further purification. These traditional methods, while simple, have been lifesavers for generations and continue to be used in many parts of the world, especially in emergency situations or areas with limited resources. They provide a crucial means of accessing clean water when modern infrastructure is unavailable or compromised. The resilience and ingenuity of these methods highlight the importance of traditional knowledge in ensuring safe drinking water for all. Section 5. Modern marvels, advanced water treatment. As technology advances, so do our methods of water purification. The need for clean, safe water is more critical than ever, and modern treatment plants are rising to the challenge. Modern treatment plants now employ sophisticated processes to remove a wider range of contaminants. These processes are designed to handle everything from industrial pollutants to microscopic pathogens. Coagulation and flocculation are commonly used to remove suspended particles. These processes are essential for ensuring that the water is clear and free of large particles that can harbor bacteria and other harmful organisms. Chemicals called coagulants are added to the water, causing tiny particles to clump together, forming larger, heavier particles called flocks. This step is crucial for the subsequent removal of these particles. These flocks are then easily removed through sedimentation or filtration. Sedimentation allows the heavy flocks to settle at the bottom, while filtration captures them in a filter medium. Filtration technologies have also advanced significantly. Modern filters can remove not only physical particles but also chemical contaminants and microorganisms. Activated carbon filters, for example, are highly effective at removing chlorine, organic compounds, and other impurities that affect taste and odor. These filters work by absorbing contaminants onto the surface of the carbon particles. Membrane filtration, such as reverse osmosis, uses a semi-permeable membrane to remove a wide range of contaminants, including salts, heavy metals, and microorganisms. This technology is particularly useful for desalinating seawater and treating wastewater. Disinfection is the final barrier against harmful pathogens. This step ensures that any remaining bacteria, viruses, or other microorganisms are effectively neutralized. Chlorination, the most common method, adds chlorine to kill bacteria and viruses. This method has been used for over a century and remains a reliable way to ensure water safety. Ultraviolet light disinfection uses UV rays to destroy microorganisms' DNA, preventing them from reproducing. This method is chemical-free and effective against a wide range of pathogens. Ozonation, another effective method, uses ozone gas to kill pathogens and break down organic compounds. Ozone is a powerful oxidant that can eliminate even the most resistant microorganisms. These advanced treatment methods ensure that our water is safe and clean, even in areas with heavily polluted water sources. By continuously improving and innovating, we can meet the growing demand for clean water and protect public health. So let's talk about water purification at home. It's, a critical step in ensuring the water we drink is safe. Many households use simple methods like boiling water, which can kill most bacteria and viruses. There are also more advanced options, like water purifiers and filters, that can remove contaminants and improve taste. It's all about finding the right balance between cost and effectiveness. Moving on, treatment plants play a vital role in providing clean water to communities. These facilities use a series of processes to remove impurities and pathogens from water. First, large particles are filtered out. Then, chemical treatments are applied to eliminate harmful microorganisms. Finally, the water is tested to ensure it meets safety standards before being distributed to homes and businesses. It's a complex but essential system. Now, let's address the water challenge in developing regions. Access to clean water is still a significant issue in many parts of the world. In these areas, people often rely on rivers, lakes, and wells, which can be contaminated. Efforts are being made to improve infrastructure and provide sustainable solutions, like rainwater harvesting and solar-powered purification systems. It's a tough challenge, but progress is being made step by step. Finally, let's discuss global water security. As our world continues to grow, so does the demand for clean water. Climate change, pollution, and overuse are putting immense pressure on our water resources. International cooperation and innovative technologies are crucial in addressing these challenges. By working together, we can ensure that future generations have access to the clean water they need to thrive.